In this video, I'll show you how to solve the ALEKS problem called using the van der Waals equation of state. This is the van der Waals equation. It's just a corrected version of the ideal gas law, which is PV equals nRT. So the van der Waals equation has these extra terms just kind of built into it. And you'll notice that the van der Waals equation has two additional constants in it. You know from the ideal gas law that P is the pressure, N is the moles, V is the volume, T is the temperature, and we know R to be the ideal gas constant. And in this van der Waals equation, we have these additional constants A and B. The first two questions that were being asked in this ALEKS problem are what are the units of A and what are the units of B? It is pretty easy for you to look the units up for A and B. The units of A are atmospheres times liters squared over mole squared. And if you're interested at all about where those units come from, because this term right here is being added to pressure, which you know is in units of atmospheres, the units of A need to contain the units of atmospheres so that these two terms can be added together. In addition, A is being multiplied by N squared over V squared. Those terms have units. This has units of moles, this has units of liters, and A needs to have units that will cancel out the units of V squared. So the liter unit is on top so that it's going to cancel out V squared. And A also needs to have units to cancel out the mole squared. So that's going to be down on the bottom of the units of A to cancel that out. So that's kind of a little bit about where those units come from. For B, what are the units of B? Well, this term is being subtracted from volume. So B needs to have units of liters. B also needs to have appropriate units to cancel out this multiplication with N. N is moles, so B needs to have units of liters over moles. The next two problems are asking us to do some calculations. So this first problem is going to give us the value of A, and it's going to give us the value of B for a particular gas. It doesn't matter what the gas is. And it's also giving us some other information as well as telling us that we have a temperature and we have a molar volume, and it wants us to calculate the pressure of this particular gas. So that just means that we're going to be plugging stuff in, plugging these terms into the van der Waals equation and solving for pressure, which is going to be a little bit tricky in terms of the algebra, but I'll show you some tricks to try to make it a little bit faster. Now, a couple other things before we start plugging stuff in. Our temperature in this problem is going to be given to us in units of Celsius, and we need to convert that temperature into Kelvin before we can plug it into the equation. We're going to do that by adding 273.15 to that temperature, and I don't want to mess this up, so I'm going to use the calculator. 273.15 plus 80 is 353.15 Kelvin. And then also ALEKS is giving us a molar volume. So a molar volume is the volume of 1 mole of gas. So that means for this particular situation, the number, the amount of moles that we have is 1, and the value of the volume is 0.391 liters. And again, that's what this molar volume represents. It represents the volume when you have 1 mole of gas. So we're going to plug everything into this van der Waals equation, and we're going to be solving for pressure. And like I said, this is going to be some rough algebra, but we can definitely do it. So I'm going to start with P for pressure plus the value of A, which is given to us in this ALEKS problem. It's left the units off 5. I don't know what just happened there. P plus 5.507. I'm going to leave the units off of everything just to try to save space. That's my value of A, so I'm just kind of following along here. And now I am going to be plugging in N squared over V squared. There's my N and my V. N squared is just 1 squared, and V squared is 0.391 squared. And so that is, all of that is this term right here. Now I'm ready to do this term. So next I have the volume, again, that's the 0.391 liters, minus the number of moles, which is 1, and the value of B, which ALEKS gives us as 0.0651, and that is equal to nRT. N is 1 mole. That's this number right here. R is the ideal gas constant, 0.082 0.06. Again, that's a constant that you probably know, but if not, you can look that up. And where are we at? We are right here, NR, and last but not least, we have our temperature in Kelvin, 353.15. 353.15. So this is a little bit hairy because we are solving for pressure, which is embedded all the way over here. And the advice that I'm going to give you for solving this problem kind of as quickly and painlessly as possible is to solve this portion on the calculator and solve this portion on the calculator first. Actually, we can solve this math here as well. So we're not going to try to expand anything. Going from left to right, pressure plus, I'm going to carry out this math right there, 5.507 times 1 squared divided by 0.391 squared. That is 36.02. And now I am going to carry out all of this math right here, 0.391 minus 0.0651, and that is 0.3259. And then last but not least, I'm going to carry out the math on the right side of the equal sign, which is 1 times 0.08206 times 353.15, and that is 28.98. And what I'm going to do next is divide both sides of this equation by 0.3259 so that term will cancel out on the left-hand side. So I'm just going to cross it off from the left-hand side, 0.3259 on the right-hand side, and that simplifies to pressure plus 36.02 is equal to 28.98 divided by 0.3259, 88.92, and now it's pretty straightforward to solve for the pressure. We're going to subtract 36.02 from both sides, and that gives us a pressure of 52.9. To 3 significant figures is what ALEKS wants, 52.9 atmospheres. Now, the last thing that ALEKS wants us to do in this problem is carry out that calculation again, but using the ideal gas law. So now we're going to do it using PV equals nRT, and the idea here is that ALEKS wants you to see the difference between the answer that you get using the van der Waals equation versus the ideal gas law. So for the ideal gas law, again, we're using the exact same variables, the exact same values, although we don't have A and B anymore. We're using the same values for the other variables. Our N is 1 mole. Again, I'm leaving the units off just because I'm trying to save space. R is the ideal gas constant, 0.08206. The temperature in Kelvin is 353.15, and the volume of this gas is 0.391 liters. And so now we're going to carry this out. Now, doing problems like this makes the ideal gas law seem really easy to work with. 0.08206 times 353.15 divided by 0.391, and that gives us a pressure of 74.1 atmospheres. You should absolutely expect these two numbers to be different. In this case, they're pretty drastically different, but the couple of versions of this problem that I solved, there was like a 20 to 30 atmosphere difference between these two numbers. So don't be surprised if they are drastically different.